All right. Hello, everyone, and welcome. Thank you for joining us today for our webinar. Presenting today will be Peter Cook, our training manager, covering rigging, hoists, and load securement. I'm Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon, and will be your host today for this webinar. We are recording this session, and as I said earlier, the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording via email after the session. Everyone is in listen-only mode. That just helps us really capture a much better, higher quality sound during the recording. And we encourage you to ask questions in the Q&A pane on the right side of your page. I'm happy that several of you are already using it to answer my last question. And just so you know, after each webinar, we pick the question that we feel has the greatest appeal to our readers. And we choose it and we feature you and your question on our blog the following week. This is something we started about 5 or 6 months ago, Peter, and it's been great because it just gives us additional content for our blog. It helps us share the news of the webinar. And what I've decided to do now, whoever we pick, I'm also going to send either a CMCO polo shirt or golf balls or something fun, a hat. I'll give you some options because we really appreciate great questions. So again, if your question is chosen, I'm going to send you something after the fact, and then you can see your name on our blog the following week. So that is my side note for today. Thank you for your attention. At this point, I'm going to go ahead and turn the meeting over to Peter so that we can begin.
Okay, thank you, Gisela. So what we're going to cover today is we're going to define AC and DC current, understand brake components and functions, cleaning and maintenance. And so we're going to get into that and basically just checking air gaps. And these trainings, just a quick disclaimer that they are not a substitute for attending a hoist technician training or a substitute for maintenance manuals or anything like that for hoist. This is more just informative so you have an idea of how things work, and if you do have any specific questions, you should either call CM or a certified technician or consult an attorney for further information. So we have two types of current. Let's go start out with AC or alternating current. You can see there's the power factory there, and basically what AC is we go from a negative to a positive, and it kind of alternates back and forth, and it passes through zero voltages, but that would be typically AC current, which our houses operate on, and a lot of things that operate on AC current. But it changes direction, so it can go either direction. DC current only flows in one direction. So a lot of us did this in grade school, where you take a battery and battery, of course, has a positive and negative, and it only flows, and it's allowed to flow in one direction. Okay, so that would be direct, which is called direct current. Okay, so if we take a wire and wrap it around a nail, we create an electromagnet. So a soft metal core made into a magnet by passage of electricity current through the coil surrounding it. So basically, I don't know if you ever did that experiment in grade school, but that creates a magnet. But that's basically the basis for an electric holding brake and hoist. It's a very large electromagnet, and we use that very simple principle, but just at a higher voltage, of course. So here's a typical AC brake, and I'll show you different designs. But every electric hoist is going to have some sort of electric brake, and there's the components of the brake, and really we're going to focus on the brake field, the brake springs, the coil. We're going to talk about what all these do: shading coils, friction discs, intermediate plate. But basically that is a magnet, and you see that air gap there, right here. You see that air gap is very important. It's a very small air gap. Maybe it's sometimes the size of a business card, but it varies from hoist to hoist and how the air gap operates. And basically what we do is we have a coil that is the wires wrapped around a core, and that gets magnetized, and that basically will pull that gap shut and allow that very fine gap right here to transfer between all the friction plates and allow the motor and the gear train to spin, which allows the hoisting action in either up or down position. So kind of isolate the coil a little bit. So there's the electromagnetic field. It's created when the motor is energized by sending voltage to the motor. So in the event that the power is cut out, it de-energizes, and the spring action will grab the friction discs, which stop or hold the load. So, two very important things, right? The coil, which releases the friction discs, and the springs are very important. So then you can kind of see why that gap is important as well. And so that's basically how the brake works. So let's take a closer look at the brake field. On an AC brake, you'll see that it is not one solid piece. It looks like, at first look, it looks like a solid piece of metal, but you'll notice that it's riveted together. And if you look very closely at this picture, you'll see, I don't know, depending on how your resolution is from where you're seeing this presentation, but these are all individual plates and they're laminated together. And we need that type of design in an AC brake to allow that brake to cool. And we also have shading coils. And this shading coil here, it helps maintain the electromagnetic field because of the AC currents and the fluctuations of the current going back and forth and actually passing through zero voltage. That can affect the magnetic field. So what these shading coils do is help maintain that electromagnetic field. And I kind of, it's not a direct comparison, but similar to how a capacitor would work for a start motor, that it would lag behind line voltage and create the magnet to help the motor keep spinning. Well, the shading coils, in a sense, kind of do that for magnetism. And so without those, and if those were to fall off or get damaged in any way, then you hear a lot of chatter or a loud noise or a loud humming that the brake doesn't operate quite right. Okay. And then these laminates are very important in how these rivets and everything stay together, that they don't start to separate. There is a lacquer on there that helps to insulate them a little bit, as well as help keep that brake cool. But that's one of the main, if you ever look at a brake and if you see that type of setup with the rivets, you pretty much have an AC brake there if you can see that. So here's a brake fully disassembled so that you can kind of get an idea. I showed you the brake couple slides that was assembled. So here it's fully disassembled. Of course, here's the coil to the brake, and that's, again, the wires wrapped around a core, a steel core. And there is the brake field I just showed you with the shading coils. Okay, and then it's also a braking surface. This plate here also ends up being a braking surface, the bottom part of that plate. The spring pressure, and that's those spring pressure is sized by torque, and the engineer sized the appropriate torque. So you never want to substitute springs or think any spring would work. They are designed to have a specific torque and hold that load. So you never want to vary from what the manufacturer supplies. And each brake is different depending on the horsepower of the motor of each hoist. Each brake is designed for the horsepower of that motor. Okay, and then we have our friction discs. You can see the friction discs here are splined. Okay, so those are directly connected to what's called a gear, called a brake hub, which connects to the gear train. So when that brake is closed, that engages the splines on that gear, which end up holding the load. And you can see this orange material is a friction, that's the friction material. And eventually that will wear during time, and that can get glassy or can get contaminated. And we would want to inspect that, or these plates can warp. Again, it can draw heat if it's not set properly, but just in general, when you have friction causes heat, and so too much heat can also cause damage to the brake. And then we have our base plate. Again, the intermediate plate, that's our braking surface as well. And then our base plate, which anchors it to the hoist and is also a braking surface. So those are all the components of an electromechanical brake. All of them, again, are very similar in operation, but they may look different. But they all have a similar concept of how they work. They just cannot. I'm going to show you as we progress here some variations on that and what they look like. And then here's a DC brake, and this is from the Lodestar. And there's one similar that's also on the World Series hoist, which is a wire rope hoist. We also have one similar on the Shopstar hoist, just to name a few. But it's a solid steel structure. And we cut one here to show. You can see the coil, the brake coil, which is not, in this case, is not removable from the brake. But this is the brake coil. And again, there's our steel structure. Okay, and our brake gap, you can see, is right here is the brake gap. Okay. DC brakes, you usually start to see DC brakes in larger capacity hoists, such as wire rope hoists, things of that nature. They seem to have a softer release, less wear and tear, a little bit better for inching. So typically a DC brake is a better brake than the AC. Both are very good brakes. They function very well, but a DC brake is usually considered a better brake than the AC. And there's the bottom portion of it. Now, it's probably why I show this picture here is you're wondering, oh, where's the springs? So we had the brake field, right? And you can see these right here. These are the individual springs here. In this case, you have many springs that apply the pressure to the friction disc, which you can't see. In this case, you can't see it's covered, but there'll be a plate that sits on the friction disc inside here, and when this field is magnetized, it'll pull that plate up and allow the friction disc to spin free. It'll be a spline friction disc on a brake hub, similar to what I showed you on the exploded view of a brake. Okay, but just again, it looks different. Okay, but again, you see the similar function: springs, coil, and you'll find friction discs and friction surface plates in there. So how do we convert? How do we go from AC to DC? So our hoist itself, we supply AC power to the hoist for hoist operations, and then we have to convert that to some portion of that power to DC to operate a DC brake. And so we have to put in what's called a rectifier. And a rectifier is very similar to the best thing is you ever see if you go in your sump. If you have a basement, those of you who have basements or sump pumps, that would, anytime you get water that flows through a valve, and that valve only allows the water to go in one direction, which is out of your house. And if for some reason it backed up, it could not come back into your house. So the same thing with a rectifier. Rectifier is a series of diodes, or if you will, kind of compare them to valves, and it will only allow the power to go in one direction. Okay, so that will convert the AC to DC. So it can't go. So the AC wants to go back, and it can't because of the diode or the gate that stops it from going back. Thus, we now turn the AC to DC. Okay, and so this is a small rectifier that we put in the Lodestar hoist. Rectifiers can look different as well, and I'll show you some pictures of that. So in a wiring diagram, if you look at a wiring diagram, that would be the symbol. If you see for a rectifier, you'll see those symbols, or a diode. So you can see there, current is going in one direction, and the AC wants to go back. Boom, it can't. It stops right there. And so if I can kind of put it in, whoops, let's see if we can get this working again. I'm sorry about that. And so you can see here the AC, this is the one for the Lodestar that I showed you is coming in. Oh, it wants to go back that way. No, it will not let it. And so it will flow, least amount of resistance, and there you go. And it flows, and it's going to try to go the other direction. It won't, so it's forced into the brake in only one direction, and thus we get our DC power. Okay, and then we go to the output, DC output. Again, it can't, it can only go in one direction. Okay, so that's pretty much how a DC rectifier works. So again, I said they look they can vary, they can different. This is a rectifier that we use in the 700 series hoist. We use one similar in the World Series hoist. This one example I'm showing you is from the 700 series, and it converts 115 volt AC voltage to DC. And it basically comes off the transformer, and the transformer on that particular hoist has a H91 hot and a 92 common. And when you operate dependent, it'll send the voltage to the dial, which creates basically the trigger or the switch, which will allow the voltage to go through to the brake, and it pulls in at 100 volts DC. And then once it's pulled in, once we have that power, we pull in the discs, and it's 0.16 seconds. Then we use a 10 volt DC holding voltage, so it has a lower voltage for holding it. So again, less wear and tear, things of that nature. Because once we're pulled in, it's easier to hold that magnet in once it's pulled in. Okay. So it looks different than that. So there's another module that looks different, but it is a rectifier. And so these are the things you're looking for when you see these things. Okay, there's a rectifier. It must be operating a brake. You look at your brake to see what you got there. Well, you got AC or DC.
Peter, at this point, if I can jump in quick, I'd like to launch a polling question for everyone.
Oh, great.
And for those of you on an iPad, you're just going to have to send me your answer on the Q&A pane because it won't work. But for everyone else, so what is one difference between an AC brake versus a DC brake? Is it A, or number 1, AC brakes have rectifiers, 2, AC brakes have riveted laminated plates as part of the brake field, C, or number 3, AC brakes have a brake coil, or AC brakes do not need friction discs? Again, the second one is AC brakes have riveted laminated plates as part of the brake field. If you all can please vote, that would be great. We always like to kind of gauge, I guess, some interaction here. Oh, it looks like it's pretty much split between A, B, or the first, second, and third. So, Peter, 70% on average are voting for the second one. Can you tell us the right answer?
Yeah, those that voted for 2, right? That is one of the differences. You would have shading coils as well as riveted laminated plates for your brake field. That's pretty much of an AC brake setup. AC brakes do not need rectifiers. Those are for DC brakes. AC brakes, all brakes have a brake coil. Okay, so we do need that coil to create a magnet. And brakes need friction discs, so it wouldn't be number 4, because otherwise it wouldn't be a brake if you didn't have a friction surface.
Okay, great. Thank you, Peter.
No problem. So looking at maintenance of the brake, so one thing I want to be very clear, you always got to obtain the proper maintenance manual for the hoist. Each brake is a little bit different. No 2 brakes are alike between the hoist and even between capacities of hoist. So you always want to check the manual and get the latest manual, read what the manufacturer says, be sure you get properly trained on how to do it. Don't work on it with the power. Don't work on a brake with the power on. So you want to use proper lockout, tagout procedures, as well as if you're going to disassemble or even working on the brake gap, you want to secure the hook lock. Meaning, so if you were to by mistake make too big of a gap, and you could release the hook lock, which is heavy. So you want to secure that hook lock to be sure nothing's going to fall out of the hoist. Okay, and then you also want to be sure no one is underneath the hoist working while you're working on a brake. So some quick safety advice to do that before you begin to work on a brake. So one of the main things is please be sure to turn the power off and lock out, tag out properly.
Peter, a quick question has come in, and I'm going to go ahead and ask it now. I know the difference between the 1 horsepower and 2 horsepower brake is the strength of the spring, but how do you achieve this with the DC brakes?
Well, you would still have the same, you still have the strength of the spring as well. The DC brakes do have springs as well that apply holding pressure.
Okay. All right. Thank you.
Yeah, I don't know if an example I showed you, there were spring in that one silver. If I can I'm going to go back a few slides just to kind of show them.
I think there might be other people that have the same question. Thank you, Peter.
These are the springs here. You have all these individual springs doing that. So see all those springs? They will apply the pressure. So there are springs there. It's just you cannot see the springs when the brake is assembled like you can on the one that I showed you in the beginning. I'm going to go back again. This is one that the springs are exposed. You can see them, and on this one the springs are underneath. Here you can see all these individual those holes there. Can you see my arrow, Gisela?
Yes, I can.
Okay, so those are all the springs that are in there, and they have to go in a certain spot. If you were to disassemble that and they were to fall out, you would definitely need a drawing to know where all those springs went.
Peter, just really quick, it could be possible that he's asking if there are different spring rates for the DC brake, just like with the AC brake.
Yeah, they're definitely. Those springs are sized, to apply enough pressure on those. So yes, you just do not want to get ordinary springs. So yes, the springs are sized according to what horsepower of the motor and how much weight that it needs to hold.
Okay, got it. Thank you.
Okay. So again, we can do a lot. We can do maintenance on the brake and check. So we can check we can ohm it out, and in maintenance books they'll tell you what your ohm readings should be, so you can set your ohm meter to there and you can get a resistance reading. That's one way to check to see if your brake coil is functioning properly. Again, no power is on, and so we can get those based on what a manufacturer of that brake says that the resistance needs to be. So that's one way to do it. And then if you had a short or anything like that, that certainly would find it. The next thing we can do is check the air gap. Okay, so if the air gap is too big, the magnet may not be strong enough to release the brake, so the motor will drive through the brake, causing heat, and we do not want heat. Again, heat is very bad in a hoist, and one of the things we try to eliminate because of duty cycles and things of that is heat, and then a lot of heat can damage the brake. And again, if the air gap is too small, right, so we don't have enough air gap to transfer through those friction discs, we'll be driving through the brake, causing heat in the motor and the brake. So it's important to check that air gap. And so people ask, how often do we check that? And at least, depending on service, but at least once a year when you're doing your periodic inspections, I recommend that you pop the cover off the hoist where the brake is located in and check the air gap. It doesn't take long to do. You can do it in a matter of a minute and check the air gap. And then if you're not comfortable adjusting it, if someone's in maintenance and they're just doing the inspection, then of course you want to get someone in that knows what they're doing, especially if you know the air gap is out of adjustment. So you want to take a feeler gauge, okay? And in the feeler gauge here, you can see the brake field. You want to check it on each side of the brake. You want to check in the front. You don't want to stick your feeler gauge all the way through. You want to check it in the front here. You want to check it in the back. And then same thing on the other side of the brake field. You want to check it again on the other side. And then the springs, you would uniformly adjust them accordingly. So these top adjusting nuts, you would then adjust those top adjusting nuts accordingly, and that would raise or lower your gap. Now, if you look at it and the gap is way out of adjustment, that could be an indication that your friction disc worn, because as the discs wear and get smaller, obviously the gap is going to get larger. So you may need to inspect your friction disc. So if you find in a periodic inspection that you're way out of adjustment and you're not trained properly to do it, then you want to call in somebody that can do a full-blown brake inspection and look at that. We do have a video for that we did on the Lodestar. If you go to if you go into YouTube and type in Columbus McKinnon and go to the Columbus McKinnon channel, there's a video on how to set the classic brake, which is similar to the brake you see here in this picture, and also how to set the DC air gap brake. So we have a video on that. So if you, after the webinar, you want to go to that, you can go check that out. Okay.
So Peter, how do you know when to check the air gap?
Yeah, the air gap, like I said, doing a periodic inspection, we highly recommend to do it. The ASME guidelines say a hoist can be checked in place, and the need to remove any covers is up to the technician. If everything, basically how ASME reads, if everything is checking out and they're not finding, the hoist is operating, is holding properly and stuff like that, and typically what it reads is no for evaluation either, but up to the hoist technician. When we do our schools, we highly recommend that you pop the cover off and just take a feeler gauge and look at that brake. Like I said, you're already up there on a scissor lift. It doesn't take a lot more time to just open it up and look at it. And so that's when you should do it.
Okay.
Or the other thing, Gisela, if they're seeing any problems, like if they raise a load and it's drifting, that's a problem that the brake is an issue, and maybe there's a gap issue or probably friction disc issue. So that would be a good time to say, obviously you would have to shut down the hoist anyway and immediately check the brake.
Okay. All right. Thanks.
So there it kind of gives you an idea of the friction discs. You could, with the plates, with everything on top, if you can get in there, you can, without even disassembling the brake, if you had a pair of calipers that you could measure the gapping between the plates. On this particular one, you could do that without disassembling to see what those gaps, or excuse me, what the thickness of the friction discs are. And again, you would have to go into the maintenance manual to figure out what the minimum thickness is allowed and also the gap. Okay. But then again, if you're not trained properly, if you want to disassemble brake to inspect everything, you again get trained properly to do it. So springs. On some hoists, such as the Lodestar, we have color-coded springs, so there's a certain color code depending on the horsepower of the motor, and the maintenance manuals will tell you what color-code springs are needed. And on some hoists, basically, if you just do the gap correctly, that puts enough pressure on the spring to have enough spring pressure. And there's others that you may have the gap, but you might have to measure the spring height, and so that's another variation of a hoist. And this is one, I believe this is from the Cable King hoist. And if you look in the Cable King maintenance manual, not only do you have to set the gap, but then you have to measure the spring heights and have the correct color for the pressure. And you measure those spring heights, and it has to match what it says in the maintenance book. Now, we tell people don't mess with them if you don't have to. Because usually they are set properly because there is a locking screw that goes on top of it. But it is a check that you need to look at. And so if it checks out, we recommend not messing with them, and then check your air gap accordingly. But that's just, again, another different style brake. It has 4 springs on this one, and so it's set up a little bit differently. So springs, color codes. I know, like on the coffin units, I don't believe they don't have any color codes. You just do what you do with the air gap, and then it'll provide enough pressure. So again, checking the maintenance manuals are very important. So let's take a closer look at the DC brake here. And the gapping, the brake, that picture somehow the gap moved on there. And the air gap is actually, if you look at my pointer here, that's the air gap, not where it's pointing underneath. Somehow that just the graphic kind of moved on the PowerPoint. You cannot set this air gap on a Lodestar, so it's a maintenance-free one. So basically, when that air gap gets out of spec, then it's time to replace the friction disc, or you replace the entire brake. It's up to whoever is looking at it on what to do. So there's the air gap right here. You would check it with a feeler gauge around. You know, I'd go around and check it, but you cannot tighten it down. You cannot set it. It's a non-maintenance one. That's one of the features for the Lodestar. To have non-maintenance of doing that. And again, we have a video showing how to set that, or excuse me, how to check the gap, but you can't set it. This is the Shopstar hoist. Now it looks very similar to the Lodestar. Okay, on some very old Shopstars, there was a gap setting to check, but the ones we currently produce today, or we've done in the last 10 years, are you have to in order to check the correct air gap, you have to disassemble the brake on the Shopstar. Okay, so let me, and this is a DC brake on the Shopstar, which has diodes. The diodes are the rectifiers, which are located on the contactor. It's such a small hoist that we don't have room to put a rectifier, so we actually just use 2 diodes that are in the lines on the lines feeding the brake from the contactors. So you have to take these. So a lot of people make a mistake on this hoist, and they're looking for a gap, and they don't see one, and so they start loosening these screws up, and they'll create a gap, which just messes up the gap even worse. And so you have to disassemble this unit. Okay, and if you look here, you have to take a couple steps you have to do. You have to measure the base plate, and then you have to measure the disc and the brake armature. This is basically, and I talked about that steel plate. So that silver brake coil sits on top of the steel, this steel plate, and when it's energized, it'll suck up this brake. It'll take this metal disc and move it toward, obviously comes off the friction disc and moves towards the brake coil. But we can't check the gap. The only way we can check the gap is we look at the thickness. In here, this is 0.272. We measure the combined thickness of the brake, friction disc, and armature, and then we subtract it out, and that gives us the gap. And so when that brake disc wears, it's going to give us a different number. So in the manual, it tells you when the brake gap exceeds 0.012 inches, then you must replace components on there or the friction disc. So it's a different way to check it. And that also has a large spring underneath the coil. There's a large spring that sits underneath the coil on that disc. And if I go back to that one picture here, yeah, you can barely see it. In there you can kind of see it. It shows it a little bit, but not really, don't see it. But it sits inside. Once you take this apart, it'll fall out, but it sits inside this cavity in here that's internal.
Peter, I'd like to go ahead and ask another polling question, if you don't mind.
Yeah.
Okay, what is needed to convert from AC to DC current? A rectifier, shading coils, riveted laminated plates, or brake springs? If you all can vote, please, that would be great. A rectifier, shading coils, riveted laminated plates, or brake springs? Wow, Peter, it looks like 65% have voted, and everybody voted for rectifier. Can you tell us the right answer?
Yeah, that's the answer, and we've been talking about that. The rectifier is the answer.
Great. Excellent job. Boy,
And the shop,
it never happens that
shop
everybody gets it right. Excellent. Thank
I'm
you.
doing a good job teaching here, right?
Yeah.
The shop star, you'll be looking for a rectifier, like I said, and you won't see it. They're very small diodes that but if you look closely at the contactor on the shop star, you will see black wires, and then it almost looks like, then you'll see in the center of the wire, it's real fat, and that's the diode. That's basically the rectifier for the shop star. You'll see two of those, and then you'll also see a little surge protector that's put on the shop star to protect those diodes from, because it comes right off the motor so that they don't damage the diodes. The current doesn't damage the diodes. So anyway, just food for thought there. The 700 series is kind of looks uniquely different, and basically all these brakes that we've been looking at are dry brakes. Okay, and typically an electric brake is a dry brake, meaning if it got any oil contamination on there, you immediately have to replace the friction discs. On the 700 unit, which is unique, the friction discs sit in the oil bath in the gear case. So kind of unique. The coil, where the electric is, the coil actually sits here. This is the brake coil. So there's on this 700, you see this kind of bucket, which I call a bucket, a blue bucket with a single screw in the center of it. If you take that bucket off, underneath it will be a blue cylinder, and then that cylinder, which we see down here, that is the brake coil, okay? And there you can see the spring. There's the spring pressure, and that basically creates a plunger, right? So this is, you can see this rod here is a steel rod, and then a steel washer that gets connected to it. Whoops, I'm going to go back there. Sorry about. Oh man, fat fingers say. I apologize. Trying to show too much.
I think so.
And I'll get back there. I apologize for that, everybody. So if you look back down towards the bottom, there's the steel rod, and what that does is what that plunger sticks in. There's seals in there so oil can't come through, but that plunger will put pressure, and you can see up here on top here, it will put pressure on the brake discs and seal, and actually will cause that gear train to lock up or to stop spinning. But it's unique because it sits inside an oil bath. Okay, but it's one of the easiest brake gaps to adjust that we have, even though it's a very large hoist. It's one of the easiest brake gaps to adjust. So you remove that cover. There's a single bolt in the cover, and what that'll expose is this blue cylinder. I call it the blue can, but it's fairly heavy. It probably weighs a good 20 pounds, maybe a little less than that, but it's fairly heavy. So you want to disconnect your power, obviously, lock out, tag out, and then disconnect your leads. Okay, so there's a set screw here. You can see on number 2 here, there's a set screw. That set screw is holding that cylinder in place, meaning that so it's not allowing it to rotate. So you want to undo that set screw, okay? And then if you turn that cylinder clockwise, that will basically tighten down the cylinder, and there is a white button on there. It's a nylon button, okay? And once you get that button flush, so if you look at it and it's not flush with the outside of the can, then that means you have to tighten it down some more. So you tighten it down some more, and that little button will become flush with the outside of that blue can, and then basically you just set your brake gap. And then if you wanted to do a check, once you power up the unit, you can hit the up button there, and that should pop out 1/8 of an inch when it's operating properly, okay? And so how do you know when to further go into that hoist is for evaluation? Well, one, obviously if you're seeing drifting and you've set the gap right, and by meaning that button is flush and it's working properly. But if you're seeing any drifting or anything like that, then obviously you would have to disassemble and get into the gear case to look at that brake. The other thing is if you're tightening it down and you can't get that flush anymore, is a good sign the discs are worn, or you can't get that, you can't set it flush. So again, that would be reason to go in further to do that. And that's once you do that, it's a fairly big job. Again, we talked about securing the hook blocks and things of that nature. So anytime you're working on brakes, secure that hook block and cut off the power. I can't say that enough. But once you set that brake, like I said, it's one of the easiest brake gaps to set. It's just a button indicator, boom, you got it. And then you can see, then you reset that set screw right there. You always want to reset it and then reconnect your leads. So I like that one. It's one of the easiest ones to set. So in conclusion, what did we learn today? One of the trained technician shall be doing the brake inspection. So if you haven't been properly trained or you're not comfortable with it, don't do them. Always refer to proper maintenance manuals, because as you've seen here, and I just gave a few examples, all those brakes were different. Even though they had the same function, they all had a little bit of a different way to set them, a little bit different way to look at them. So that's important that you get those maintenance manuals. Again, shutting off the power is very important. Securing the hoist block is always important. And then once you, if you do work on any brake, you want to do an operational. So you can refer to ASME B3016 after servicing the brake, and it'll go through and you basically tell you to lift light loads. Basically, it's 50 pounds times the number of load supporting parts of either chain or wire rope. And you want to check the functionality of it, be sure it's functioning properly. All right?
Peter, I have another question. If a hoist technician disassembles the brake for inspection or replaces any part of the brake, does a load test need to be performed?
And we at CM recommend doing that. It's a recommendation if you disassemble, put it back together. But again, if it's an underhung hoist and you go to the ASME B16 document, the brake is considered a transmission part, not a load suspension part, and so no further load test would need to be done. You just do an operational test. So no, you would not have to do a load test, and you would be compliant with ASME standards. Now again, we always recommend doing a load test, but if you go by the ASME document, you would just have to do an operational test, and that's it. And so no load test recorded. I remember when I first started learning about hoists, it kind of was a shock to me, like, wow, you don't have to do a load test. And no, you don't.
Okay, we have a couple more questions that came in. Actually, we just got a third one. So the first one is there a recommended replacement interval for springs due to fatigue? Springs are one of the things we can't, we can't test. And so basically if you feel that the spring's an issue, so you rule out, you replace friction discs and things of that nature, and you're still getting drift, you're most likely, the time to replace those springs. I don't have any interval or time frame that we don't have that information, but if you ruled out everything else, then it would be the springs. And some people just if they're going to be replacing the friction disc, sometimes they'll just get new springs and put it in. So it's up to them. Okay, and this one is, what is the correct way to test a rectifier?
You can do for your ohms meter. So your ohms, you have a 9-volt battery inside the meter, and it will only, so you will see that if you put your lead, and if you basically got to look at the wiregram to look at the direction of it. On the Lodestar where we put that, you saw that red dot, that's the output. So it should only go in one direction. So as you put your ohms meter and your leads on there, you'll see that you'll be able to get a reading in one direction only, and if you try to go the other direction, it won't read anything. So that's one way to check it. On the 700 unit, I don't have I don't have a picture of it, but on the 700, that brake module that I showed you that was for the 700 unit, we have in the maintenance manuals for that, there's a little circuit that you can connect. It's a light bulb test, because basically you want to see about the holding voltage. So you can put a connect the light bulb to it, a 115 volt to it, and we have a board here in our training center that we show that. And basically, you flick the switch, and the light bulb will burn bright real quickly. In a matter of seconds, it'll burn real dim. That's how you check the one in the 700 unit. And boy, I wish I had a picture of that. Geese, what I'll do is I'll take a picture of it. So if you want to email it, I'll send you the circuitry for that. And so everyone can get that. If they have 700 units or World Series hoists, that's the way to check those. And then also in those World Series, there's a little, or not the World Series, on the 700 and 800, there's a little glass, well, it's not glass, it's a plastic box. That could be, you can look at that, and it could have like a burn or charring to it. That would be a good sign that it's probably blown.
Okay, Peter, we just have a few minutes left, and I promised 2 people that we would answer their question, and we've got several more since then. So those of you after 3 and 4 who ask questions, Peter will directly respond to. My apologies, but we don't like to take you beyond our 45 minutes. So number 3, when does brake wear or damage turn from a maintenance issue to OSHA ANSI issue during inspection?
Well, you're required to inspect the hoist, and as far as OSHA and ANSI is concerned, again, the technician is to inspect, and at least minimum once a year, and more depending on severity of service. But whether the further evaluation is needed is up to the technician of when to replace. So, or you look in the maintenance books, and some hoist manufacturers may give you an interval of when to do that. Okay, but they're not going to. The OSHA and ANSI documents are not going to spell out anything, is because each like again, you saw all those individual breaks and designs that I said. There's a lot more than that than I just showed in this presentation. So it's up to the technician whether they want to evaluate further.
Okay, and number 4, where is it? How does CM handle static versus dynamic brake torque ratings? Do you assume that they are one and the same, or do they differentiate based on empirical testing?
I will refer that question to an engineer.
Okay.
And I'll get back. I'll email that answer out. Okay. I don't want to answer that wrong. I'm not a brake engineer, so.
No, that's perfect.
I kind of have an idea, but I don't want to say it wrong.
Okay.
I will answer his question.
Okay, perfect. And for those last people who just typed in some questions, like I said, I've been pinging each of you individually, but Peter will respond to you directly. Okay, Peter, why don't you go ahead and cover the last couple slides, and then I have one more polling question as things wrap up here. But again, we really respect your 45 minutes, and we don't like to run over. So go ahead, Peter.
Okay. So those are interested in learning more about all the different various brakes and the hoist, we have a chain hoist repair certification course. One in Charlotte in June, another one in near Buffalo. We're in between Buffalo and Niagara Falls. It's our Niagara Training Center. That's the only place we do all the hoists. We do the wire rope there as well because the wire ropes are so big. Any other center we just do chain hoists because we don't send our wire rope hoists around. They just get damaged. We also have overhead crane and hoist inspection class. That's coming up in May. That's in Charlotte as well. That is more of the whole entire system, crane systems, things of that nature. We don't really go over brake. We talk about the various types of brakes and things of that nature, but we don't really get into individual brake settings like we do in the chain hoist repair and the wire rope repair. So one's the entire system from the runways on down, and the other classes are actual hoist repair, where we take hoist apart. We don't do that in overhead crane hoist inspection class.
Okay, Peter, I'm going to go ahead and just launch the last one, the last poll. So we just want to know, for those of you who haven't attended before or maybe haven't answered this question, are any of you interested in becoming a certified CMCO chain hoist repair technician or taking any inspection or rigging training? Yes, within 1 to 3 months. Yes, within 3 to 6 months. Yes, within 6 to 12 months. Or no, you're not interested. We just want to gauge. That is great because, like Peter says, we offer training all over the country at different places. I'm in Charlotte, Peter's in New York, and we're actually getting ready to, I'm going to be sharing news about our training facility in Charlotte. We've added quite a bit to it. It's very exciting just to make it a little more convenient to those of you that can't make it up to New York or the other places. So, okay, I'm going to close that. And then, Peter, can you just go to the last slide? Thank you for all of you that voted. And I'm just going to take it from here on the last point. For those of you on social media, please connect with us. I noticed that someone on this webinar just reached out to me on LinkedIn. That's awesome. We love that. We have a Columbus McKinnon page on LinkedIn. We have Google+. If you're on Twitter and like to tweet, we have our industrial, which is CMCO Live. And by the way, on our website, cmworks.com, we have all of these icons. You can just click on them and it takes you to that page. As I said, you're going to get a link to our YouTube channel where this video will be posted, so you have it for reference. And we also have a Facebook channel with tons of pictures, tons of stories. We love sharing stories. And we also even have an Instagram account as well as a blog. So, and again, someone from today will be chosen, their question will be chosen for the blog, and I'll be in contact with you if it is, and I'll send you something. So thanks again to all of you. If you have any final questions, feel free to type them in now. Peter will still answer them directly after this via email. And or if you have any questions for either of us, feel free to do that now. And we just thank you for coming. We know you're all busy, and we appreciate your time to attend this live session. And just appreciate your interest in what we're doing, and join us next month. I don't know if it's been confirmed, Peter, if we're going to be doing the RFID topic.
Yeah, I got to confirm that with Troy yet, but pretty much.
I'll tell you what I'll do. I will hold off on sending the follow-up email to everybody with the link until we know what the next webinar will be, so that you can register from that email, okay? But thanks again, everyone. Again, you can keep typing in your questions. I'll keep it open a few more minutes. Have a great day and great weekend. Bye-bye.